Yes, recording.
Hi everyone, good morning. Today we'll discuss data engineering concepts, tools and techniques. Data is new oil and data has gained paramount importance and data is increasing continuously. When you look at the spendings by the organizations around the world, on the spend on on-premise databases, it's going to be 6% year on year in the coming 5 years. Whereas spend on data storage on cloud is going to be 12% year on year growth in coming 5 years. Data is getting generated every day by IoT devices, by manufacturing equipment, and we are ourselves huge data producers. Every second we produce data, and we have mobile devices in our hands for pretty much considerable time within 24 hours, and mobile phones that we have in our hands produce huge data. That data, it may be related to our personal information, our browsing history, what we search for, and what kind of news we read. Everything is captured, collected, stored, processed, analyzed, and used for various purposes. May it be changing our mindset, or may it be marketing some product to us, or targeted campaigning for selling products online. Our data is captured, processed, utilized. So let us start discussion on what is data engineering, what are tools and techniques, what are the different roles in the field of data engineering. Data engineering is the process of collecting data, storing data, transforming data, and preparing data for descriptive, prescriptive, and predictive analytics. These are just three words: descriptive, prescriptive, and predictive analytics, but these have a huge meaning. Let's consider building blocks of data engineering: data collection, data modeling, data warehousing, data lake house, data wrangling, creating data models, and big data engineering. These are the building blocks of data engineering. This is not all the data engineering. There are quite a few other concepts, but these are the major concepts in the field of data engineering. Data is collected, data is stored, data is processed, and data is utilized for various purposes. These are the building blocks of data engineering. I'll elaborate a little bit on each one of these aspects of data engineering. Data is collected from various sources. These sources may be internal to an organization, or these sources may be external to an organization. Data is collected from social media, from Facebook, from LinkedIn, from Google, from YouTube, or wherever. And there are third-party data provisioning agencies. These also collect data, and they provide data to organizations for analytical purposes. Data may be available in different forms and formats. It's available in the form of files. Data is available in the form of relational databases, table structures. That is structured data. It is available in files. Files are of different types and formats. File may be tab delimited, these may be comma separated, these may be pipe delimited, or there are XML files, JSON files, Parquet, ORC. These are different file formats in which data is stored, and data is then collected from all those heterogeneous sources in raw form as it is in the first phase, and then a modeling is done, a structuring is done, proper structuring is structure is created to accommodate that data which is coming from multiple sources, and data is then cleansed, deduplicated, and brought into proper format, and then finally it is stored in the form of table structure. For storing data, there are different technologies, there are different ways the data is stored. As we proceed further in this presentation, we'll come to know what are the different ways. So data warehousing, data lake, and data lake house, these are the data warehousing concepts. Data wrangling, this is again process of preparing data which can be utilized for data science purposes. Creating data models and big data engineering is a different field altogether. Let's discuss some of the popular databases. There are more than 200 databases. Out of those 200 databases, some of the significant and popular databases I have enlisted here. Oracle is very old database, very famous, very popular. Many of us have had an exposure to that. Teradata, this database is used mostly for creating data warehouses and data lakes. Microsoft SQL Server, there are many data warehouses available in Microsoft SQL Server. This is Microsoft's proprietary database. MySQL, it's open source database. Now Oracle owns it. DB2, IBM. PostgreSQL, MongoDB, this is no SQL database. Cassandra, this is an offering from AWS. Snowflake, this is very popular cloud database today. Single store, this is again a very not very popular but very efficient, performance efficient database. Microsoft Cosmos DB, Google BigQuery is next to Snowflake. This is gaining prominence, importance. This is very fast and very popular. AWS Redshift and AWS Athena, to name just a few, these are the databases. Databases are the systems which allow us to store data in the form of tables. And tables may be related with one another through primary key, foreign key relationship. So there could be master tables, transaction tables, and there is a relationship between master table and transaction table. For example, items. So list of items and attributes related to items can be stored in an items table, and as and when a new item is added to the store, we add that item to the table once, and that is used, and that item may be sold or an item may be purchased. So whenever item is sold or purchased, that is a transaction. So depending upon the quantity of items sold or purchased, the inventory of that item goes down or goes up. So this is typical transaction processing. I mean, I'll explain what is the difference between transaction processing and analytical processing. So data is stored. So whenever we store data, we perform certain operations on that data. We perform data manipulation operations and then data query operations. In data manipulation operations, we insert data into a table, we delete data from table, we update data from table, make changes to the existing data. These are update operations. They're called CRUD operations also: create, see, R, read, U, update, and delete. So CRUD operations are performed on data, any data. So typical OLTP system, online transaction system, processing system, these are point of sale systems. Whenever we go to any store or a hospital or any service, we take the front end of that system, allows us to make data entry, and the data is stored in the back end. So typically we perform insert operation, we perform delete operation, we delete data which you don't need, we update data if there are some changes. So these are insert, update, and delete operations. And if there are more insert, update, and delete operations, such a system is called online transaction processing system, because continuous transactions are happening and we are processing those transactions. So in such cases, our requirement is we should be able to do fast deletes, fast updates, and fast inserts. But OLAP systems are different. These are called online analytical processing systems. In this case, what we are doing is we are not performing insert, delete, and update operations. What we do is we store data in database and we use that data only for and mostly for analytical purposes. We perform queries on that data. We might want to know do time series analysis, like how the trend is going on. We might want to know how different geographies are performing. Take for example case of a supermarket. One supermarket operates, say for example, in 25 states of a country, and now you want to know what are the sales of different stores in different geographical areas within a month, or what are the sale by all of the stores in a month. So here we are referring to the or in a quarter. Here we are referring to time duration. In another case, we are referring to geography. And if you want to know sales of a particular product within a geography or during a time span. So here all these attributes like time, geography, product, these are called dimensions. And what we measure is the performance of those products. It may be sales. These are generally quantities. The quantities are called measures. So we perform calculations of measures across different dimensions. We can do slicing and dicing. For example, we can look at a product sell across a geography. So what we are doing is we are measuring performance of the product across geographies. So geography is dimension and sales is measure. Or we may want to know sales of a particular product over quarter 1, quarter 2, quarter 3. So quarter 1, quarter 2, quarter 3, this is the time is the dimension, and along that dimension, we are calculating what is the sales of that product. So product sales is measure. So the quantities are calculated against different, or for example, we want to know sales by customer. So customer may be a business entity or it may be an individual person. So when we calculate performance of a product against individuals or organizations, so organization is a dimension and individual, again person or customer, is a dimension. So in case of, so what we're discussing is online transaction processing. They are only meant for taking data, updating data, inserting and deleting data. So these are update delete intensive operations on OLTP systems, but OLAP systems allows us to calculate performance of sales performance or some other performance criteria along with the dimensions associated with them. So such systems are called OLAP systems, and OLAP systems allows us to do fast query. So inserting, deleting and updating is not the important criteria here. What is important here is, are we able to get the results in a short span of time from the database? So these databases are modeled differently than these databases. These are modeled for faster query performance, and OLTP databases are modeled for faster insert and update and delete performance. So there are different database related concepts: normalization, relational modeling. We create primary table, master table, and then transaction table. We create primary key, foreign key relationships among them, and we structure database like this. And this mostly relational database modeling is utilized for OLTP purposes. And for OLAP, there is star schema modeling. We create dimensions and measures. Snowflake is hybrid approach. It's neither very denormalized like star nor very normalized like relational modeling. So it's a golden mean between these two, partial dimensional modeling and partial relational modeling, that is snowflake schema. Previously, data warehouses were built across by using star schema or snowflake schema, but data volume is increasing day by day, and because of the increasing volume of data, these days data lake is the new concept. Data lakes are nothing but dumping grounds of data. Initially, data is taken as is in raw form, and it is stored in data lake, and from data lake further it is processed and made ready for analytical reporting purposes. Data lake house is a concept. It's just a different version, different concept in cloud world for data warehousing. So data warehouse and data lake house, these are similar but different in some aspects. The difference is data lake house allows us to do huge storage. They allow us to store different data types: relational data, structured data, semi-structured data, unstructured data. It could be pictures, it could be uh, voice recordings, these could be video recordings. But that facility was not available in traditional data warehousing. Mostly that was around relational databases, table structure, properly formalized table structure, and they allowed only input in the form of files, and data was stored in rows and columns. But data lake house allows us to store all the variety of data. It could be simple tab delimited, comma delimited, pipe separated files. This could be Parquet file format, ORC file format, or these could be voice recordings, or these could be video recordings. So these data lake houses are mostly part of big data engineering. Big data engineering encompasses all sorts of data types. It supports all sorts of data types, and big data engineering supports huge data sets, millions of records, trillions of records. But that was not the case in case of traditional data warehousing. Data size was not so huge, and variety of data that was coming was not so much. There was only mostly relational data. But data lake houses allows us to store all sorts of data. There are three V's in data, big data engineering: volume, variety, and veracity. Huge volume of data, variety of data, structured, semi-structured, unstructured, and veracity, continuously changing data. Everything is integrated into one place, and off of that database that is exposed for reporting purposes. Then reporting is done off of that variety of data, so that allows us to have much better picture and clarity into the data that we are holding than the traditional only descriptive analytics. Traditionally, I'll come to, we have not discussed yet what analytics is. First, we are just talking about how data is collected, how data is stored, and then how data is made ready for presentation and reporting purposes. When it is made ready for reporting purposes, then reporting tools connect to the databases and do reporting in the form of dashboards, pie charts, bar charts. So finally, what we are doing here is the non-meaningful, just raw data is coming to our systems. It is getting cleaned, transformed, changed, and we are storing it in proper format. Once it comes in proper form and shape, then we are exposing it to reporting services, and reporting services then give data a pictorial format. The raw data, which did not make any sense at all to us initially, now comes in the form of picture, and one picture is worth 1,000 words. And once it comes in the form of picture, like raw bar charts, pie charts, dashboards, interactive dashboards, the data becomes much more meaningful, very easy to understand, and one doesn't need an expertise or very deep knowledge or deep understanding of the business to understand data which is presented through reporting tools. So the popular tools we'll definitely discuss as we proceed further. Just to sum up, what we have discussed is how data is collected, how it is stored, how it is modeled, and how it is finally exposed to reporting tools for finally presenting it to the business. Now we'll discuss popular ETL tools. Informatica is a very popular tool. This is number one for so many years. More than 15 years, Informatica is the tool of choice for ETL processing. ETL stands for extract, transform, and load. Data is extracted from multiple various databases. So data may be existing in MySQL, DB2, whatever database. There are 200 plus database. In any of the database, data may be existing. Data may be existing in the form of files, or some applications create files, generate files, and these files are transferred by using file transfer protocol through some scripting language. It may be shell scripting mostly, or it can be any other form, or Perl scripting. And those files are utilized for extracting data from and loading into a properly created structure. It may be data warehouse or data lake or data lake house. So ETL tools are sit between sources of the data and data warehouses or data lakes. And they play a very important role in cleaning the data, deduplicating the data, in transforming the data and bringing it in proper reportable form. Informatica is very popular tool. Talend is an open source tool, but not that much popular as Informatica is. AWS has its own offering. Glue it is an ETL tool. And now Azure Data Factory. There was a service by Microsoft. Its name was SSIS. That was SQL Server Integration Service. That was on-premise ETL tool of Microsoft. Microsoft took this tool to cloud with some modifications. More or less same transformations, same facilities are available in Azure Data Factory, but it is in cloud. Azure Data Factory is an ETL tool, a cloud ETL tool. And for big data engineering, Python is used, programming language, and Scala again is a programming language. These are used for ETL processing in big data engineering. So a lot can be done by using Python and Scala. So far we have discussed databases. Prominent amongst them are Oracle, SQL Server, MySQL, and quite a few others. ETL tool is Informatica, and programming languages are Python and Scala. So what we understand so far is in data engineering, we need to have understanding of at least one relational database, very thorough understanding. We need to know at least one ETL tool like Informatica or Talend or AWS Glue or Azure Data Factory, and we need to know Python very well. I'm giving more emphasis on Python because Python is the language of data warehousing or ETL processing, or even for data science. Python is gaining prominence now. Scala was very much extensively used in the initial days, but the use of Scala is diminishing now, and use of Python for data processing is increasing now. So these are the popular ETL tools. Now we'll discuss popular reporting tools. So we collect and store data in databases. We process data by using ETL tools. And once data is ready for serving, like kitchen activity is done now, your dish is ready. Now with some changes, you're going to serve it. And two most popular reporting tools are Microsoft Power BI and Tableau. Oracle also has OBIEE, Oracle Business Intelligence Enterprise Edition, but OBIEE was more or less proprietary only for Oracle data sources. So throughout this discussion so far, you have not discussed how data is collected in the first place. As you all know, data is collected through ERP systems mostly for enterprises, and there are three most popular ERP systems. Number one is SAP, number two Oracle applications, And number 3, Microsoft Dynamics. Microsoft Dynamics is not very popular, but Oracle and SAP are fairly popular. So these are the front-end systems which collect data and store in databases. Then ETL tools lift that data and shift into a purpose-built spatial database and load that data into that. And there we create data warehouses or data lakes or data lake houses, and data from these reporting tools then connect to those data lake house or data warehouse or data lake, and they report data in the form of dashboards, pie charts, bar charts, and they bring data in pictorial format. And now data becomes very meaningful. Initially, we were not able to make, or any layperson wouldn't be able to make sense out of the data. That is raw data scattered here and there, sitting in multiple places at multiple storage devices. But now once it gets integrated, clean, deduplicated, and ready for reporting, Microsoft BI and Tableau report it and give it to the business. There are different data storage technologies: traditional disk storage, Azure Blob Storage, that is from Microsoft, and AWS S3 Bucket, that is distributed data storage system from AWS. Now we'll discuss data engineering tools and techniques by cloud providers. Microsoft Azure Data Engineering, this is also a certification. Microsoft Azure Data Engineering stack consists of Microsoft Cosmos DB, Microsoft SQL Server as databases. They have Azure Data Factory as an ETL tool for transforming data and loading data into warehouses, lake houses, and data lakes. And they have Azure Databricks for big data processing. Azure Databricks requires understanding of Python scripting. Much of the work is done in Python. Azure Databricks provides framework for big data engineering on Microsoft. And combination of these Azure Data Factory and Azure Databricks is Microsoft Synapse Analytics. Microsoft Synapse Analytics is a combined offering for ETL as well as for reporting. Data engineering, as I said, on Microsoft is built on Microsoft Cosmos DB, Azure Data Factory, Azure Databricks, and Azure Synapse Analytics. So that is the offering from Microsoft. Data engineering tools and techniques by cloud providers. Google BigQuery, it's from Google. This is gaining prominence now. Among the cloud databases, Google BigQuery is very popular, gaining prominence, and use is continuously increasing. Next only to Snowflake. Snowflake is #1 cloud database as of today. Google BigQuery is next to Snowflake. So we need to have understanding of today everything is shifting from on-premise to cloud, and cloud trends continuously we see cloud adoption is increasing very fast. So with increasing cloud adoption, Google BigQuery is gaining prominence, and also Snowflake is gaining prominence. And single store is another database that is very popular, not very popular, but very strong, very performance efficient one. But as of now, we can focus on Google BigQuery. The #1, of course, is Snowflake among cloud databases, and #2 is Google BigQuery. But this adoption of Google BigQuery is increasing very fast. AWS has AWS Redshift, AWS Athena, and AWS DynamoDB. These are the databases from AWS. Now I'll talk about the Microsoft Certified Data Engineer. Suppose someone wants to start career in data engineering. Where can he start from? So one can start understanding databases first. To start with, one can start with Microsoft SQL Server, MySQL, Oracle as databases, and one can get into Microsoft certified Azure. One can aim for Microsoft Certified Azure Data Engineer certification. First, one can complete this track. This includes Microsoft Cosmos DB as database, Microsoft SQL Server, these are the databases. Then ETL tools, Azure Data Factory and Azure Databricks. So one doesn't need to focus so much on Databricks in the initial stages. One can start off with Microsoft Cosmos DB and Microsoft SQL Server, and then one can learn Azure Data Factory, the ETL tool of Microsoft. And Azure Synapse Analytics also can be left for later. I mean, and Azure Blob Storage. So when you talk about blob storage, this is the concept of cloud storage, Microsoft Cloud Storage. So in the olden days, one needed to have good understanding of operating system before one can start learning anything. Or one needed to know how Linux works, how Unix works, how to write shell scripts, or if it is Windows, how to write programs, some scripts in Windows. That was the basic understanding one needed to have, or how to connect from client interface, command line interface to database, how to connect from Windows to Oracle server. So one needed to have good understanding of operating system. But now everything is shifting from on-premise to cloud. So one need to have proper understanding of how cloud technologies work. So one can start off with Microsoft Azure. Microsoft Azure has got one fundamental certification, AZ900. So AZ900 gives us an idea about how Microsoft Azure cloud works, what are the regions, how data is stored, how it is processed, how servers are maintained, how networking is done. So that is basic. So I would recommend, if somebody is aiming to go for Microsoft certified Azure Data Engineering, first thing, learn Microsoft SQL Server database. First thing, learn, do AZ900 course, understand the essentials of Azure cloud. After that, learn Microsoft SQL Server database and do DP900 certification, Azure Data Professional Fundamental certification. So now you know how cloud works. Now you know how databases are hosted in cloud and how to work with databases, how to create table structures, how to insert data into them, how to get data out of them, how to write stored procedures and all that. Number two, and then learn Azure Data Factory as an ETL tool. So if you know Microsoft SQL Server, if you know how to work with Microsoft Cloud, and how to work with Azure Blob Storage, and if you know how to work with Azure Data Factory, you are half a data engineer. So this is one path. And once you have got mastery over all these concepts, then you can start looking into Azure Databricks. But before you can learn Azure Databricks, you need to have very strong understanding of Python. So Python is something which is very, very important. If you are trying to make a career in data engineering, Python is very essential. Very, very essential. So one has to have proper understanding of Python. So I would rather say, start with Python. Start with Python, then learn how Azure Cloud works, do AZ900 certification, then learn how Microsoft SQL Server works and how to work in Microsoft Cosmos DB, and do DP900 certification, Data Professional 900, and then learn Azure Data Factory. After you have done this, you have understood how data is collected, how it is stored, how it is transformed by using Azure Data Factory. Now, what you need to know is how to present it to the end user or business. For that, you will need to learn reporting tool, and Microsoft Power BI is from Microsoft. So then learn Power BI. So in short, I mean, in summary, what we can say is learn Microsoft SQL Server, Azure Data Factory, and Power BI. Very short journey. I mean, but the other things are also very important. So we can learn these, and one can become, and then one can write Microsoft Certified Azure Data Engineer certification. So this whole journey of becoming a Microsoft Certified Azure Data Engineer, if you spend 2 hours every day, should not take more than 3 months. So if you give 2 hours per day every day for 3 months, so within 180 to 200 hours, you can become Microsoft Certified Azure Data Engineer. and that is your first entry into the field of data engineering. You can land into data engineering and then you can expand to big data engineering. So big data engineering is the real data engineering. So this includes HDFS, MapReduce, Yarn, Apache Hadoop, distributed data computing, Apache Hive. This is an interface like for writing SQL queries on top of files. So partitioning, buffering, and SQL. Apache Spark, and I must mention along with Apache Spark, Python, core SQL streaming and scripting. So we talked about, okay, I'll talk about batch processing and stream processing later on. But just remember streaming, Apache Scoop, Apache Flume, and Apache Airflow. This is for scheduling. For scheduling our jobs, Apache Airflow is used. So that is big data engineering. But before one go into big data engineering, one has to understand that Microsoft Data Engineering and study the concepts of Microsoft Data Engineering, database, ETL, and reporting. There are different career options. I have mentioned just a few, not all of them. Data engineer, it could be Microsoft Azure Data Engineer, it could be Snowflake Data Engineer, or it could be data engineering AWS certified data engineer, or Google certified data engineer. If one has to become Google certified data engineer, one has to learn Google BigQuery. Data modeler, data architect. Data architect, so the modeling architecture of data has to be done. The pipelines have to be built across the systems, across enterprise, from different systems in an enterprise. Data is collected, then pipelines are built, and then data is stored into some storage form, and then data is utilized for data science purposes or for data reporting purposes. ETL developer, this is for data cleansing. So if one has to become ETL developer, one has to know Informatica or Talent or Azure Data Factory. So if one has to be cloud-centric ETL developer, one can learn Azure Data Factory. Then data scientist, so and cloud architect. So you should know how to architect data in the cloud, how to create data architecture in the cloud. And then there are roles there are so many projects, data migration projects. So data, you might want to migrate data from on-premise systems to cloud systems. So there are data migration experts. So that is another role. So these are the roles and career options available in the field of data engineering. So that's all. I mean, I hope you got an understanding of what data engineering is all about, what a data engineer does, what his role, what are the tools and techniques and technologies available in the market. So now I open it for question answer, and now I'll answer your specific queries. If something you are not able to grasp due to my fast speed or something, so let's look into questions. Please send your questions through chat or okay. Please send your questions, or you can ask. Say bye. Okay, what is Microsoft Azure used for? Microsoft Azure is cloud offering from Microsoft Corporation. Microsoft Azure, anything that we are doing traditionally by using on-premise infrastructure can be done by using Microsoft Azure. Microsoft Azure is cloud technology. The specialty of Microsoft Azure is gaining importance, and it's expanding very fast. The reason is there are so many Microsoft implementations around the world. So the companies who are Microsoft centric, or we can say Microsoft Shop, for example. There are a lot of technologies in Microsoft. They are converting to Microsoft Azure. Microsoft Azure is gaining prominence, but it has some problems, especially they're telling that there are billing related problems. There is no clarity on billing. Support is very good from Microsoft, but the billing is not predictable. The customers are not able to identify what will be their spend on cloud implementation all. But apart from billing, it's gaining importance. So Microsoft Azure is cloud offering. I hope you this answers your query. Java is uh, not important. Java is not important because if you know Python, you can do everything that you can do in Java, and Python is more extensively utilized in data projects rather than Java. Or we can say Python is number one, Scala is number two for big data engineering, and Java stands at number three. But if you know Java, good, you can utilize your Java knowledge. And if you know Java, you can program better even in Python and Scala. Java is and there are many implementations in Python and Scala, but not many in Java, as many in Java. Kafka is streaming, its latest data engineering tool. If so, how to study it? Kafka is not the latest. It's been there for a long time. Kafka is definitely, I mean, if you know Python, if you know Scala, definitely learn Kafka. So if you are essentially focusing on big data engineering, then Kafka you must learn. So how to study it? I mean, I don't have, I mean, the concrete answer because I cannot show you correct resources for this. But Kafka is definitely important, but not Kafka is not everything. Kafka is just, in big data engineering, Kafka's contribution is not more than 10 to 15%. So there is a lot of other technologies like Python, Scala, then HDFS, Hadoop, and all that. These concepts are more important. Kafka can be learned and not very difficult. So if Asif, you can connect with me one-to-one, and we'll discuss it later on. Next question: are SQL operations compatible with big data frameworks like Hadoop? SQL operations, the Hadoop SQL, the Hayu is for big data as SQL is for relational databases. So what Hayu does is Hayu stores data in the form of files and gives you SQL-like interface on top of that. So you are writing SQL queries, but data is coming off of files. So as data, whenever data comes from files, it's definitely much faster query response time compared to when data is coming from databases. So Hayu is the offering in big data for SQL operations. So yeah, in Hadoop. So Hayu is the counterpart of SQL. I mean, not say counterpart. Hayu is the offering in big data for. So you can use Hayu in place of. But that allows you to write essentially SQL queries. Not much difference. So prima facie, it looks like you are writing a SQL query, but you are writing on top of Hayu, and then data is coming from files. Response time is very fast. Free website and resource for learning complete data science. Any data scientist here? If any data scientist can, I mean, I know quite a lot of resources, but I'm not a data scientist, so I'm not the right person to answer this question. You can start small and then build on top of that, but there is no point in one thing I can tell you for sure, that it doesn't make sense to go through different trainings, and I mean 10 15 different trainings and learning something. Just stick to one training, one training from one course, complete it end to end, understand it thoroughly, and then you can look for the other resources. But if you jump from one to another, then you will end up spending a lot of time learning not much, without learning much. So you can stick to one, I mean, for data science. What should be the sequence of learning? Tableau and Spark is one concept dependent. Spark and Tableau are not dependent upon each other. Spark is totally different. Spark is for data, ETL, for ETL, and taking streaming data and loading into data warehouses. And Tableau is reporting tool. So we can say learn Tableau and then Microsoft Power BI. So these are two different reporting tools. So if you have to have understanding of reporting tools, Tableau and Microsoft Power BI, very small tools. Within 2 months, you can learn Tableau as well as Power BI. So I would say learn Tableau and Power BI. So Power BI and Tableau and Spark are not related to each other. Spark is for creating data. Tableau is for reporting data. So no conceptual similarity between them. One moment. For career gap, students of 3 years, if I learn SQL, Power BI, and Azure Data Factory, then can I have any opponent? Definitely. And yes, so if you complete, as you have mentioned here, Power BI, Azure Data Factory, I mean, very crisp, not so many. I mean, you have made it very simple already. Only thing is that you have to get yourself certified, get Microsoft certified Azure Data Engineer certification, and definitely huge scope. And along with this, if you do Azure Synapse Analytics, nothing like that. I mean, your chances will increase manifold. So this entire SQL, Power BI, and Data Factory will take not more than 2 months, and Synapse Analytics 1 month. So within 3 months, dedicated efforts of 4 to 6 hours a day, you can do that. 4 to 6 hours a day consistently without any gap. Do data engineer, data scientist, and data analyst work together, or they are different fields? Data engineer, data scientist, and data analyst, definitely they work together. They are dependent upon one another. So the data engineer prepares the data, and data analyst give insight to data engineer. Data engineer prepares the data, and data scientist utilizes this data and does the final goal. He wins the match. Data scientist finally, because data scientist gives guidance to data engineer as well as data analysts. So the scientist is at the top, data engineer, and data analyst works across. Data analyst role is across. So data analysts help data engineers as well as data scientists. So data scientists and data engineers work with data analysts. Data analysts need to have functional understanding of the business, how business works. He doesn't need to know technology in depth. But data engineer and data scientist, they need to know, data scientist needs to know this statistics very well, and also NumPy, Pandas, and many other Python libraries. He need to have understanding, and he also needs to have understanding of the business. So data engineer and data analyst plus data scientist is one role. Data scientist is on the top of the hierarchy. Data engineer works for preparing data, and data analyst works across with everyone. What is the future roadmap for ETL developer? We are working
sir, a small extension to the previous question, sir.
Yeah, tell me.
This is fine, sir. A small extension to the previous question, actually.
Yeah.
Sir, you said for Microsoft SQL Server, Azure Data Factory, and Power BI, it needs 180 hours, you said, sir, for at least 2 hours a day. It needs 3 months, you said, sir. Along with these three, should I need to learn Python too, sir?
Python, there is no option for Python is ABC.
Okay.
Python is ABCD. You must learn. I mean, there is no exception. Python and SQL. SQL and Python, there is no exception. SQL and Python are must.
Along with these two, I have to learn Power BI and Azure Data Factory.
But one important thing I'm telling you, don't go in depth.
Okay.
Just have initial understanding of Python. That's enough for you.
So can I learn Python from YouTube?
Python. Don't spend too much time on SQL. Learn just enough. Don't go in depth. But the ADF and that reporting, you have to learn that in depth.
Reporting in the sense of Power BI.
SQL and Python is never-ending journey.
Okay.
You continue to learn throughout your life in SQL and Python. SQL looks very simple, but it's not as simple as it looks. When it comes to multiple tables, complex queries, joins, materialized views, inline views, creating huge reports, or building views on top of database. So there is a lot in SQL that can be learned. So first, learn minimum SQL, learn minimum Python, learn maximum ADF, and learn maximum Power BI.
Power BI.
Hope this answers your query.
Sir, though I am having a career gap, do I get any opportunity if I do the certification, sir?
So career gap doesn't matter. What matters is what you bring to the table.
Okay.
What matters is not knowledge. What matters is skill.
Okay.
So knowledge is different and skill is different. Skill is about performing, converting concept into reality, and knowledge is about information that is stored in your mind. Unless converted into feasible practical solution, which is accepted by the client, knowledge is of not much importance. So the skill is something that is important. And I'll reiterate, focus on fundamentals. Your fundamentals must be very strong. If I am telling that 3 months duration is required for understanding this, spend 1.5 months on fundamentals.
Sure, sir.
Spend maximum time on fundamentals. Fundamentals are very important. So I'm
Sure,
moving
sir.
on to the next question. Can I?
Yes, sir. Thank you, sir.
What is the future roadmap for ETL developer? We are working as ETL developer since long time. Then what would be the best career path? Data engineer or data analytics or data scientist? See, for an ETL developer, first he has to become data engineer. Complete Microsoft certified Azure Data Engineer certification. And then you can go for big data engineering or for data science. If you have got good understanding of statistics, you understand business well, and you are very strong in Python, then go for data scientist. But remember, data scientist journey is not that simple. You need patience and very hard, I mean, intensive hard work to become a data scientist. So first become a very good data engineer and good big data engineer, and then you can consider becoming a data scientist. But I'll say slowest is the fastest. Slowest is the fastest. Don't try to be a data scientist within 2 months, 3 months. Spend little efforts every day consistently over 1 year, 2 year, 3 years, and then you'll start uh, appreciating data science. Of course, I mean, we don't have, I mean, the industry doesn't allow us that long time. But what I say is, if you don't have strong, solid foundation, don't aim for, if at all you have to become a data scientist, I would say, don't become a data scientist without a coach or a mentor. First, get a mentor to be a data scientist and work under his guidance. Don't try to do on your own. I mean, that will be a lot of effort, but you won't get the kind of results that you would expect. So since engineer, okay, I hope that answers your query. Next is
The same question. So thank you for clarifying that question. And as you said, Azure, which one is best? Cloud one or Azure one or AWS? To take
okay. Okay, I'll tell you.
Yeah.
I told you that there are some billing related issues in Microsoft Azure, but they are hybrid. I mean, they allow everyone to onboard on their platform. It may be Unix, Linux, or Google Cloud or AWS, whatever. They offer very good hybrid support. I mean, multi-cloud support, Microsoft. But AWS, on the contrary, doesn't care much about hybrid support because they are so strong and so established in the market. But their billing is simple, and AWS is very good for infrastructure. Infrastructure as a service, it's very good. Those who are in the field of networking or database administration or infrastructure provisioning, they can go for AWS. That's very good. But as far as Azure is concerned, in data, Azure is, I mean, currently good and gaining importance. So it depends on what is your history. If you come from Microsoft technologies, go for Azure. And if you come from networking or database administration, go for AWS. I hope I answer your query, or if you have any further query on that.
Yeah, I'm from Oracle Technologies as a developer, ETL developer. So I'm confused whether I need to go for Azure or AWS or Google.
Okay, in Oracle,
which
ETL tool which technology you have used so far?
I use so far ODI, Oracle Data Integration. It's a ELT tool.
Body you have used,
ODI.
No?
ODI,
then if you have used Body, I'll say go for Azure.
Okay.
Yeah, if you have used Body, go for Azure. Definitely, that's much better. Because the issue is, see, if there are not so many openings and expertise level required is very high, then we cannot start and just get into that field. So that there are so many openings in Azure, and you don't need a very in-depth understanding also, and you can catch it up very fast. So first get into Azure, and later on you can try to diversify, just in case if you want to, or opportunity comes to you, and you get a project of different technology. It's okay, but you can start off with Azure, I would say. If you are done body, then Azure is much better for you. There are good courses on Udemy for data science. Yes, courses, there are courses everywhere. But what matters is how much apple you eat. It's not just you take a bite and then throw it away. It's like, you take 100 apples and you take one bite from each of them. So you feel happy and contented, but you don't get enough nutrition. So that's it. So you take one course, you start reading a book, read it from beginning to the end, practice it, then go for the next. So don't, the what we can say is this multitasking doesn't work in a learning process. You have to focus on one thing, and you have to get in-depth understanding of one, and then you can move on to another. So is it the next, which certification to focus on? Agent 900 is not very special certification, let me tell you. It's not very special. It's just a fundamental certification. It only tells that you know a little bit of cloud, just like understanding operating system, like file structure, creating files, deleting files, copying, pasting files and all. It's simple like that. Not much. I mean, but you need to know the fundamentals of the cloud. So Azure 900, everyone must do. I would say everyone must do Azure 900. Everyone must do AWS practitioner. And there is one more in Google that I won't recommend, but AWS practitioner and Azure 900, everyone must do, irrespective of your technology. Data science, yeah, there are good courses on Udemy for data science, but I would say don't learn data science without mentor or coach. Don't depend on online courses. If you are so intelligent, it's okay, but there are very few people who can understand and implement, not many. If you have got that high intelligence, you can go depend on the courses. But if you think you need mentor, definitely seek help and work under mentor. They will guide you properly. What is the difference between big data engineering and data engineering? Not much. Big data engineering, there was Apache Kafka, HDFS, Hadoop, and all that. And that is for variety of data, structured, unstructured, and semi-structured. And data engineering is for both, for relational as well as structured and semi-structured and unstructured. So data engineering and big data engineering, the data engineering is subset. These are same. Just a little bit difference. But big data engineering is a specialty field, and data engineering is general field. It's like MBBS, and big data engineering is like MD. You are a specialist, and if you are doing data engineering, you are generalist. You are not specialist. That is the difference. Data science is used for aviation. There are any roles in particular? Data science is used everywhere. It is omnipresent now. It is ubiquitous. Everywhere it is going to be used, and its adoption is going to be used very fast by leaps and bounds in the days to come. So data science is new English, we can say, but not everybody can understand so easily. That's the difference. But one has to have basic, one at least need to have basic understanding of data science, what the concepts are and what data scientists do and all that. So basic knowledge everyone has to have, and those with the special skills under mentorship of experienced data scientists can learn data science. Is data science used in aviation? Yes, it's used in aviation, and it's used for predictions. In a lot of fields. Most important subject which are asked in data science interview. So the interviews are different. So it depends on which company is taking your interview. If a banking firm is taking your interview, then there won't be questions related to manufacturing domain. So it depends upon the kind of organization, the organization you are being interviewed for, and which domain that organization is going to work in. So every domain is different. manufacturing is different from life sciences, and banking is different from say manufacturing. Any good source to learn Synapse Analytics? Microsoft Learn is the best source. You can refer Microsoft Learn, and you can learn from it. And WAFA studies, WAFA, WAFA, WAFA studies. You refer this channel, WAFA studies. That's very good channel. WAFA studies. I don't know whether spelling is correct or not. You check it, you'll get it. For any Microsoft related technology, you refer WAFA studies for learning. Yeah, so these are the questions so far. Any other question?
Samir bhai, I have a question.
Yes.
Yeah, if you want to choose between data analytics and data engineering, what would you recommend is better in the long run?
So, what is your background? What is your qualification, academic qualification?
I'm BTech in electronics.
Then engineering is better for you. Analytics also is better, but you need to understand business. If you have got more interest in business, how business works and functions and all that,
Okay.
receivables, payables, general ledger, the supply chain and all that. If you have got that kind of bent of mind, then you go for analytics. How to report numbers and all that. And if you've got kind of technical mind, then go for data engineering.
Acha, in terms of number of job opportunities and compensation, both of them are same?
Compensation and job opportunities everywhere. In every field, there are so many job opportunities and there is so much compensation. Compensation depends upon your expertise. Opportunities are available everywhere. But in some fields, you need little expertise. In some fields, you need more expertise. That's it. But compensation depends upon the skill level, and there is no limit to that. So even if you know Excel and you are very, very, very expert at it, then definitely compensation will be much more than a data engineer, possibly.
Okay.
Next, did I miss any question? Hadoop, Spark, and make further scope. Okay, Hadoop and Spark, and that's just big data engineering technology. Simple. It's very small thing, not big. That's just part of big data engineering. Small part of that. Do we need strong knowledge of Linux shell scripting for data science? Not really. You don't need so much knowledge of shell scripting. Shell scripting is for different purposes. Do you coach people or provide training? I don't. Yeah, no, I will be available to discuss for 15 minutes, 20 minutes, half an hour. You can meet me personally, discuss. I have discussions over the weekend sometimes, but I don't do that actually. Strong knowledge of Linux shell scripting for data science? Not really. Do you have any specialized tools or predictive analytics? So that CPU, mem, disk, so performance data. So this question, your question, do you have specialized tools for predictive analytics? Especially so performance desk CPU. So looks you come from database administration background. Do you, Kasim? So like monitoring and all that. So
yeah. Basically, I do a capacity optimization for all our on-prem servers. Okay. So we are looking to use any specialized tools for predictive analysis, and moreover we are moving on to VCF as well slowly. So I thought it would help us to plan some using any specialized tools for predictive analysis.
So there are many who will market tools to you, and I mean they will try to sell tools to you. But unless you don't use them and understand whether they are really useful or not, you shouldn't go for them.
Exactly.
Because they will promise a lot, but they won't deliver as much as they promise.
Exactly.
So it's better to have your, sometimes Excel works much better than a very highly sophisticated tool. You would say I was better off at Excel rather than using this tool because I have to learn a lot how to use this tool. I mean, you're getting my point.
Yeah, I got it. Yeah.
And then that tool would say, no, we want this kind of data. You give me this, then I'll give you this. But that doesn't hold any good value proposition, spending so much money on that and then not getting enough out of that.
Yeah. Fine, I'll touch base with you offline.
Hi, Abdussami.
Yeah.
Hi, Abdussami.
Yes.
Hello.
Yes.
May I audible?
Yeah, you are audible.
I have experience in Oracle, PL SQL, and Informatica. Okay. I want to go for the cloud. What will be the next step to adopt that positions?
Microsoft Certified Azure Data Engineer. Is it? Note this. Azure 900 first thing, DP 900 number 2, and then Azure Microsoft Certified Azure Data Engineer number 3, and then learn Synapse Analytics and go into Azure Databricks with Python. Very good for you.
Is there no any Oracle in that instead of Microsoft? Is there any Oracle corporations we can go ahead?
No. For their OBIE offering, right? But later on, they shifted the whole ETL workload on their own ETL tool. So they became kind of a proprietary, and now Oracle is not using Informatica much. So what I'll say is, we started with Oracle, then we have propensity to look for something in Oracle. But if Oracle doesn't expand as much as the others, then along with Oracle, we also get stalled. We also don't go further. So we have to, at some point in time, leave something that we are quite used to, and learn something new. I hope I answer your query. Yes, Satyam. Who was this? Do you provide mentoring? Currently, I have completed ADF and practicing SQL and Python to concentrate on Databricks. Yeah, you're going in the right direction. Sheikh, I don't see your name completely, but you're in the on the right path. R language, R was used for analytics purposes, but now Python is taking its place. So if you know R, it's okay, but you must learn Python now. Web scraping and all, so Python is preferred choice rather than R. Hi, Nanesh. Okay, once again, for those who wish to stick to Oracle, we've been there, we have done that, we have done quite a lot in Oracle, right? So we have lived our life in Oracle. So it's time we got away from that and we got into something new and exciting. Definitely, if you're working on production support, learn Power BI. Definitely, that's very good thing. Learn Power BI and also learn Tableau, because Tableau and Power BI doesn't require much time. You can learn Power BI as well as Python, and then your profile will be better because you will have multiple options. Like you can work in Power BI as well as in Tableau. To start with, later on you can change your technologies, but to start with, you can learn Power BI and Tableau. Any other question?
Okay, Abdussami sir.
Hello.
Yes.
Yes, ma'am. Actually, I have completed MBA Finance and I want to become data scientist. Like initially, I have to learn like one by one. I have to go. First, I have to learn data analytics. Then I have to learn like.
No, not really. Not really. First, learn Python.
Okay.
And work under a mentor.
Okay.
But
so
don't do data science without mentor.
Okay. So that's what actually.
And second thing, I'll tell you, if you are done MA Finance and want to become a data scientist, stick to your aim. Don't digress. Don't digress.
But what will happen? No, if we are not getting any calls, if we are uploading the CVs into the.
Then get into something simple. learn Power BI, learn Tableau. Or I would rather say consult somebody from SAP.
Okay, SAP is different. No, SAP is have their own database. They don't work
No,
for.
you are from finance background, no?
Yes, yes. Yeah,
So
SAP.
if you are from finance, so look for some finance related module in SAP. There
So
you will be better off.
No. In SAP there is a SAP FICO, finance and controlling.
Yes.
This one is there. Module is
Yes.
there. But people, as Azure is coming, then no MNC companies are going for SAP. Like they are
Then-
migrating from total. They are taking their database into Azure.
Okay,
Because
then
the maintenance cost
okay.
is very high
I'll tell you.
in SAP.
I'll tell you. Learn SQL.
Yes.
Be perfect at it. Learn Python.
Okay.
Be very good at it.
Okay.
Learn Power BI.
Okay.
Okay. Don't learn Azure Factory and then consult a data scientist.
Okay. Okay.
And then go further beyond there.
Okay.
But
So
these three things are must. Azure, you
okay.
need to have AZ 900 you have to do. DP 900 you have to do. And then you have to learn Power BI. And you have to be very strong at SQL and Python.
Okay.
And once you have done that, consult a data scientist and learn under him. But remember, this is going to be a long journey.
Okay. But if you are getting any job, as soon as we will be completing SAP, like what you are telling first, if we learn Power BI, sooner we will get the experience in Power BI, then we can learn SQL, and then we can go for
No. Without SQL, you can't do Power BI.
Okay.
SQL is must. It's base. First
Okay,
SQL, then Power BI. Without SQL, you cannot do Power BI.
So which will be the best? Python and SQL will be the primary. Then we have to learn for the Power BI.
Primary AZ 900, DP 900, SQL, and Python. If you want to go for data science, if you don't want to go for data science, don't learn Python. Directly go for Power BI. Get a job in Power BI, and then start focusing on Python and data science. So, what is your primary focus? Getting a job or getting expertise in data science? If your primary focus is getting a job, then get a job in Power BI and SQL as an analyst, and then you can move on to data science slowly. Data science is a long journey. You have to have patience and you have to work hard. Email address. Okay, email address. I'll send. Okay, I'm sending my email address to you. This is my email, asoption@yahoo.com. But if you want to connect with me, connect within next 10 days. Okay, because I'll check email after 10 days and then I'll note down all the details. If you connect after 10 days, probably I will not check that email.
Abdussami sir, can you put in the chat box your
I
email ID?
I already put it.
No, we are not seeing. I think you sent to one person only, not to everyone.
Okay, I sent it to Nilesh. Okay. Nilesh,
please make it everyone.
Okay. I'll send it to everyone. Okay, it's a direct message. I'll send it in chat box. One moment.
We can see it. I think it is.
Okay.
Forwarded. Okay, Abdussami sir, thanks a lot for
Can you mention
explanation and so many questions.
We still have some time because we started 20 minutes late. So do you have any question?
That website which you are referring for
Wafa Studies. That's in the chat.
I could not see that.
So my chats are going to. Okay, one moment. I am sending you. One moment. Note down my email address. Send me an email within 10 days from today, and then I'll definitely respond. And first, studies the channel for Azure. Okay, now everyone got it, right? Yeah. So if you don't have any questions, can we call it a day?
Sir,
LinkedIn profile, there is nothing much on my LinkedIn profile. I mean, you won't find anything there.
sir, a small question, sir.
Yeah.
Sir, for freshers like me, do we need to join any institute or YouTube sources and Microsoft certificates are enough, sir?
Not institute, but you need to have a mentor or coach.
Okay. So
Don't do it on your own. You'll spend a lot of time and then you wouldn't know what to study. I mean, if you study a lot and then if that doesn't lead to some conclusion, no. So that's a waste of efforts, right?
So for mentors, we have only institutes, sir. Then we don't have any mentor.
Vikhar, are you Vikhar?
No, sir. It's me. It's Faiz, sir. It's Faiz Ahmed.
Faiz Ahmed, okay. So you contact me, then we can discuss.
Okay, sir.
Yeah, I definitely am not going to sell any institute.
Okay, sir. Sir, if you don't mind, can I have your WhatsApp number, sir?
WhatsApp number? No, I cannot handle that. And that's very difficult. You know, so many messages will start flooding into my WhatsApp, and then I won't be able to.
I don't take much of your time, sir. Please kindly.
Okay. As of now, you send me an email. I mean, whatever query you have, send me an email. I'll respond separately. Those who will ask me WhatsApp number, I'll give also, but you have to first request through email. Then I'll personally respond to that. Definitely.
Okay, sir. Sure, sir. Sure.
No, it is just to avoid. I mean, if some query comes to me, then it's binding on me to respond, right? And just in case I don't, I mean, that will be disrespect to you. So to avoid that, I'm requesting you to send me a query through an email, and then I'll send you a response within 10 days from today.
Sure, sir. Sure, sir.
You are in which city you are in?
So actually, because you are on the right track. You don't need to. I mean, if you are there, then they will train you perfectly. You are at a good place. There are so many YouTube channels. You just Google and you'll get so many. But channels won't help you much. They will not take you anywhere unless these are supported by some practical implementations. So if there are not any questions, once again, my heartfelt apologies to you for the initial fiasco and delay in starting the session. Maybe I'll plan one more session sometime after 2 or 3 months. That time I'll see to it that I'm very much organized and I take it in the proper way. Thank you very much.
Yeah, thank you, Abdussami Syed. We can have subsequent sessions, maybe more detailed on each topic.
Yeah, definitely. The next session. Definitely, next session will be much more organized and much more, much better than what it was today.
Today also was very good. We got very good overview from beginning to end. Mashallah, it was very nice. Thanks a lot, everyone, and thanks a lot, Abdussami Syed. Assalamu alaikum.
Thank you so much, sir. Thank you so much.